example, we're going to use a vector compare. So under vector, we see compare, and we see copy. Just like we did before, we're going to compare MI 2000 to 2010. What is 2010? Well, in the next net, we see vector copy of 2000 to 2010. So again, we're going to do a struct. We're going to build 2000. We're going to compare it to the previous scans, 2000, which is 2010, and we're going to see if there were any differences. The output here, MB4091, if it's 0 or low, there's no change. I'm sorry, if it's low, there's a change, and if it's high, there's no change. Okay, so our output now, 4091. And just like we did before, if 4091 is high, we're going to perform a send command, or if 100 milliseconds have passed, we're going to perform a send command. Okay. Again, we compare to 0 for our status message. We are using our system bit to determine if the buffer is full. And we have our first send command. This is MI 2000. We're sending to MI 2000 in our controller. We're sending to ID number 1. And this time we're sending with a length of 8. Remember, we built a vector with a length of 8. And the status, I'm sorry, the priority is high. Because it's I/O, we're going to call the priority high all the time. We want to make sure this information can get across the network. Okay. And we've added one more send command here, just to illustrate another send. We're sending MI4, which is the analog input that's connected to the EXRC1, and we're sending it to MI4 on the 570. Okay, again, ID 1, vector offsets are 0, the length this time is one single memory integer, and the priority is high. Okay. We left this based on the sends of the previous. It's a memory integer for an analog input, so the update time is, if we have a few especially, is going to be on average longer than 30 milliseconds. So in this case, it's okay to just use 100 millisecond or the change of the digital inputs to send the message. Okay. Oh, we don't have to worry about those. Okay, so that's the send from the EXRC1. If we want to close this down again, we can take a look at the receive on the 570. And now let's take a look at the input side. And we can see very simply we have message received from unit 2. MB4012 will go high. If 4012 was high, we'll go into run the mixed the struct to pull information from the vector to mixed data locations. Now again, we're only concerned with, in this example, 8 bits, so that's one single byte. We're going to take the information from the previous inputs. It's going to send it again to 2008. When it's received, we're going to store this into 2160. And this is the inputs that are displayed on the HMI. Okay. Okay. And the other piece of information, MI4, if we look at the HMI, will be received in MI4, and we've linearized it here. I don't know why this is blacked out, but I'm just linearizing the values 0 to 1,000. You see the min and max are 0 and 1,000. From 0 to 4095. So we're going to display again the analog input value on the HMI. If we want to go online with it one more time and just see it working. And again, I'm connected to the EXRC1. Okay, let me see our voltage here. And again, if I disconnect, you should see everything turn off. And I plug it back up, and we'll get our states and our analog input back. Okay, so this is the UniCAN protocol in a nutshell. What we saw here is our tools for sending messages. Again, each controller can send a message to any other controller on the network. We saw our receive message. We can have an indication of any controller having sent to us. We saw our check alive. We can check to make sure that the controllers are available. And we use the struct to build and to extract a vector of mixed data. So that struct command as well, not limited to the UniCAN protocol. We can use it in Modbus or any other communication we'd like. Okay, so that is those are the examples, and that is the information for this webinar. If there are any other questions, we can leave this open for a little bit, and you can let us know, and we can answer them for you. Thank you, everyone, for attending. And a recording of this and also the programs we used will be available on our webinars page after. So again, thank you. Thank Jason for answering the questions.